Okay, carry on.
Are you gonna do an intro?
Can you do the
Clay like hit it that
sites?
one time. You know this time? Clay was like,
Wait,
what's going on?
No,
Marrow. Marrow.
No, it's like a Pokemon. I remember telling you that, or did I just think it? Like every time I say your name, Merrick, I think like, and I think like Pokemon. I must have thought and said, I must have just thought and be like, don't tell him that. He's gonna hate me. So in my mind, every time I say Merrick, in my mind I'm saying, I know. Good morning, everybody. So, go ahead and take a look at these beautiful 3060 90s, 45 45 90s brought to you by Madeline. Make sure that your proportions are correct and that your sides are correct. Notice that in the 45s you do have 1 1 radical 2. Opposite to 30 is the 1. Opposite to 60 is the radical 3. And those just are. I want to point something else out. Any triangle, well actually any image can be dilated, right? Do you guys remember the word dilated? When your eyes dilate, what happens?
They get bigger.
Or they can get smaller, right? So you can dilate them, you can make them bigger, you can make them smaller. So if we dilate these images, we can make them bigger or we can make them smaller, depending on how we want. So there's actually some really cool things we can do with this. Since these all have a base value of 1, you can just say that this is x radical 2. So if I had a 45, 45, 90, and I know that doesn't look like it, but that's a 45, 45, 90, right? And if I told you this was 5, what's this side going to be? What's this side going to be? Absolutely. Absolutely. Because you can dilate that thing, and you just got to follow the x values on there. Same thing with same thing with our 3060 90. This becomes x. This becomes 2x, and that would become x radical 3. So you can dilate those in that fashion. Or reduce them. Okay. Okay, how was that unit circle? Okay. Is that as far as you're going? Okay, we'll see. What? If I have some time at the end, it's Friday. I want to keep it kind of laid back and a little bit chill. So as much
Wait,
as we
there's
can.
homework class? It was so hard. Me too.
So there you go. I can't go over it until people get it done. Just an FYI, I shouldn't be telling you now because I haven't done it yet, but I feel like if I say it, now I have to do it. You know how I use Class Dojo? I'm going to put the homework thing in there, and I'm going to share the passwords with your parents. And then every day I'm going to put in there whether you did your homework or not so they know if you did it or not.
That's pure evil right there.
I'm pretty grounded. Honestly, I do it more if they put due date on it. Like if it had to be done by a certain date, I'd probably.
If I took off the,
Oh, hell no.
you can go after the due date.
Wait, are you gonna do it like the day?
No, you're right. That's, I mean, if you tell me that I can do it later, later never comes, but I'll get it done at some point. You are a true procrastinator.
Like the day?
Welcome to the club.
I've been in the club.
I was born. I was born late. That was great. Okay. So we are starting the semester with trigonometry. That's good. We're still laughing. Hold on. Let me.
It's Friday.
Did you curl your mustache today?
No. Is it curly?
It's like super pointed on this side.
No, I was combing it. I must have tapped it or
Shave
something.
it, Mr. Munoz.
I'm gonna be a sage. I'm gonna grow it out like this.
No.
Okay. Refocus. Since we're starting with trigonometry, there's some things that some of y'all probably had some bad experiences with, but we have to, and I'm just going to pretend that I'm teaching it brand new, because some people might just need that, okay? So, when we're working with trigonometry, it's kind of cool because we are stuck with triangles, hence trigonometry, 3 sides, okay? And of course, if we're going to be studying that, we're pretty limited, right, with what we can do with trigonometry. Well, to start with. And then it can blow up and we can expand on it. But there's a way to associate all three sides. And I think you guys have already heard about them, but I'm going to talk about them again. There are three trigonometric ratios, technically six. We'll start with three. One is called sine, and then we have cosine. Oh, commentate. I told you, I'm starting new, I'm starting fresh. So if you have some prior knowledge, that's good, and if you don't, then we're going to learn it again. I don't like SOHCAHTOA, that's just so offensive. But we have sine, cosine, and tangent. I think you guys have heard of those, right? So let's just start with the simple ones, okay? Now, I'm going to draw just a triangle. Just a triangle. That's not what I wanted, but okay. So it'll go like this. Now, this is a triangle. Now, with trigonometry, we are working with right triangles to begin with. Later on, we'll expand to others, and we'll see how those rules apply to those. But for now, we're going to be sticking with simple right triangles, and these are three trigonometric ratios. Ratios. The ratios are simply fractions, okay? Now, in a triangle, this side here, the longest side, has a name. Hypotenuse. I hope I spelled this. No, there's no E, is there?
Yeah, there is.
You know what I'm going to do? I'm just going to call this height. I did not plan that. I did not plan that. I'm just going to abbreviate height, and you'll see that abbreviated that way forever, okay? So in a right triangle, the hypotenuse is always the hypotenuse. When is it the hypotenuse?
Always.
Always. Not sometimes, not never. Always. It always is the hypotenuse, okay? And the hypotenuse will always be opposite to the right angle. Everyone's cool with that? Cool. Now, so let's label this. We've got label A, we've got B, and then we've got C. Usually we don't deal with angle C because that's always a right angle, correct? That leaves us with two options. We have angle A, which is up here in this corner, and we've got angle B, which is over here in this corner. Ooh, excuse me. So let's talk about a couple things. There's three words you need to know. One you already know, which is hypotenuse. The other word, or abbreviation, is OPP. That stands for opposite. Opposite. And then, the other word you need to know is adjacent. Okay? Now, what does opposite mean? Is this fool opposite to me? Is that guy opposite to me? Mary Carlici. Is Carlici opposite to me? Well, he's on the opposite side of the room, pretty much. So he's on the opposite side. So it's over there, right? That's opposite to me. What's opposite to this wall? That wall. It's on the other side. Okay? Now, the word adjacent means next to. Adjacent. Okay? Which walls are adjacent to that wall? Those two, right? That one or that one. Is that one adjacent? No. You want to shout those three words? And then the hypotenuse is the? Hypotenuse. Is it ever opposite? Is it ever adjacent? No. Cannot be. Cool enough? Simple enough? All right, cool. So, let's put some stuff on here. Because that's hypotenuse, and it's always a hypotenuse, I'm not going to give it any other letter, okay? Oh, you know what, actually? I will. I'm just going to call it H. You guys cool with that? And I'm going to call this X. No, I don't want to do that. I want to call this Y. I want to call this X. You guys cool with that? Okay. So, if I'm looking for the side that's opposite of angle B, opposite of angle B, I'm looking from here, aren't I? This is my point of view. So imagine me, little me. Not that I am. Here's my point of view. Which side is opposite? That one is, isn't it? Is this one opposite?
No.
What is this one? How about this one's adjacent? Right? No! This is not adjacent.
A or H?
H.
Oh, it's the hypotenuse.
Is it ever anything other than the hypotenuse? No. So y is opposite, x is adjacent, and h is adjacent, right?
Hypotenuse.
Good. Never call it anything other than the hypotenuse. The hypotenuse is always the hypotenuse. Simple enough? Okay. Let me change my point of view to angle A. Which side is opposite to angle A? Which side is adjacent? And which is the hypotenuse? H. Questions there? Give me thumbs up if we're good. Thumbs down if you're not. This is either you got it or you don't. Okay, so let's do this. So here's what you need to know about these guys. Sine, the ratio for sine is the opposite side divided by the hypotenuse. Okay? The ratio of the sine is simply the opposite side divided by the hypotenuse. Can you close your laptop, please?
You're telling me SOHCAHTOA doesn't help right here.
I didn't say it doesn't help. I just said I don't like it.
4K.
You know, I don't like the story behind it at all. It's stupid. I will give you one later that I do like, and it's kind of fun for me. But the ratios for cosine are going to be the adjacent side, or the length of the adjacent divided by the hypotenuse. And then your tangent will be the length of the opposite side divided by the adjacent side. Okay? We'll talk about that right now. Right now, all we're doing. So if we were still talking about these things, this is h, this is y, this is x, correct? And if I asked you for the sine, and we abbreviated sin, if I asked you for the sine of angle B, then you would say, oh, my point of view is angle B. What's the ratio again? So what would the ratio be? Y over h. It would be y over h. Whatever those numbers might be. Evan, what's sine? What's the ratios for that? What sides am I looking for?
Opposite over hypotenuse.
Opposite over hypotenuse, right? So if I'm looking at angle B, here's my point of view.
Oh, and the
opposite side is y, and then hypotenuse is h.
Okay.
So whatever number those might be. So if this was 10 and 2 for some reason, then the sine of B would simply be 5. If that was true.
Less than sine now means sine of, or that's just, yeah. Oh, it's an angle.
Yes, this is angle. This is the symbol for angle.
See, now we just using the same thing for two different things.
What do you mean?
That's how you make stuff confusing.
What am I using again?
Well, because it does the same thing for like less than or greater than.
No. No.
No.
This is less than. This is a flat line at the bottom.
Wait.
Right? This is the what's it called? I forgot the name already. Where you start? We said the vocab yesterday, I already forgot it.
We did not.
The initial end, and then that would be the terminal end.
I need to write that down.
Right? So it's just a little angle, bro.
Just a little angle, bro. A little bit of angle never hurt anybody.
Here, do that. For less than.
Does it help you find like degrees and stuff?
Say that again?
Does it help you find like degrees?
Yeah, we're gonna get to all that. We'll get to that. Right now we're just building. She has questions. That's being a good student. Asking. Being curious.
I can remember once. Fully recorded.
I'm a great student.
Can I open the door, you guys?
Remember,
Go for it.
Hey, what if I asked you for the cosine of angle A? What would that be?
Oh, I got the same thing.
If I asked for the cosine of angle A, what would that be? It would be y over h, wouldn't it? Cool. That's kind of cool.
wait.
So let's go to here. To here. Let's get rid of these bad boys. What did you have here, Maddie?
1.
1, and this was radical 3. Okay, so using these two triangles that were created by Maddie earlier. Ándale. Ándale. Let me erase some of this stuff because I want to use this. Oh, you know what? I don't have to do that. Look at me cheat. So, let's put this into some context because the other is pretty abstract. Let's say I asked you for the sine of 30 degrees. What would the ratio of that be?
1/2.
What is it?
1/2.
It's a half, right?
Yeah.
AKA 0.5? Thumbs up if you understand that.
The hypotenuse is 2 right here, right?
Why is it 2?
Yeah.
Because it's along the side.
On
Triangle.
4/5.
on the 30, 60, 90. Because on 45, 45, 90,
Radical.
it's square root of 2. Okay? But yeah,
Cool. Yeah, get it.
cool. Sarah? I just didn't see.
Like a
Okay.
triangle.
Sarah, what if I asked you for the sine of 60 degrees? What would the sine of 60 degrees be? Don't do that, don't, no.
Square root of 360.
No. It's gonna be a bad day today.
It's gonna be a great day.
I mean,
Look.
James was like, "Happy Friday," so I have no choice but to have a happy
It's broken.
Friday.
It's broken. All right, you guys can look at your notes though, right? What would the sine on 60 be? Is this too easy for you guys?
No.
No, we're good. Okay, I'm just gauging, guys. What if I asked for the cosine on 45 degrees?
Be 1 over square root of 2.
It would be 1 over radical 2? It would be 1 over radical 2, right? But do we write this? Is that what we're supposed to write?
No, because you have to.
We have to rationalize it so it ends up being radical 2 over 2. So just to be aware of that, if you do see radical 2 over 2, then that had to be rationalized. Okay?
That makes sense.
Cool beans. All right. Do I need to do a few more or are you guys good?
I think we got it.
Then we're good here? Okay. So we've been talking about the unit circle, yeah? I want to make it look pretty. Or decent, at least, I should say. Unit circle. What did I say about the unit circle? It's a circle whose radius is 1. Whose radius is 1, right? Now, because we do have x, y axes, technically, the formula for that circle would be x squared plus y squared equals r squared. Do you agree or do you disagree?
I agree.
Yeah. That seems right.
Yeah? And it would just be 1. Eventually, that radius, because it's a unit circle, our radius is 1. 1 squared is just 1, right? But the buttons are working, which is kind of weird. Okay, so. We are very used to calling this, and this is the x-axis, right? And this is the y-axis. There are some associations that I need you to make with sine, cosine, and tangent. Okay? Whenever we see x that's graphed here, I want you to think cosine. I want you to think cosine. Whenever you see y values, or you see y, I want you to think sine. Because sine is asking for the up-down motion, cosine is asking for the side-to-side motion. And whenever you see hypotenuse, or h, you're really talking about r. Okay, so radius, hypotenuse are kind of the same thing in this, because that's where our hypotenuse will come from. It will be just some rotation on the radius that ends up at some angle. So here's what I mean. Let's say I put some angle here, This is the radius of the circle, isn't it? And if I kind of created a line that came straight down to x, I would be creating a right triangle where this is x, aka the cosine. This would be y, aka the sine. And r, of course, would be, the radius in this case would be the hypotenuse of this triangle that we created. Right?
Oh, so that's the right triangle in the circle.
That is a right triangle in a circle. Let's go with that.
Me no gusta.
Did it stay? Did it go?
Yeah, just shave it.
I just need a monocle now.
Please.
That's so
do.
strange on the barber.
No matter what next year we get, just show up with a monocle.
But like
What I just
gradually shave it. Like shave the mustache and then shave the beard.
1 year,
And then shave the head.
when I grew my beard out,
eyebrows.
I did a monkey tail. Have you guys seen a monkey tail?
Hair, toe hair.
You shave, you leave all of this, and it wraps around until the mustache.
That's
It's called the monkey tail. And then you take this piece off.
Oh my, let's not.
But have you heard of the rat tail?
Mr. Mooney.
Oh, that would
I'm
be
gonna get
bad.
one of those.
Mr. Mooney.
Jake.
If you shave it, make it a goatee for a day.
All right, everyone's cool with this?
Shave it gradually.
Thumbs up, thumbs down. This is okay. This is not anything crazy, right? All right, cool. Let's do this.
I'm gonna fall off this chair.
I want to make a specific angle rotation, and I want to go to where this would be, yeah, Ruja. Ruja. That would be 45, right? So I am going to make a note of that. These are 45 degrees. So that's the triangle that I would create. I did my angle rotation, and then from that point, you always go straight to x. Where do you go?
Straight to X.
Down to x. Never go to y. You go to y, you fools, you're wrong. You just lost points. Okay? Now, here's what I want to do. I want some coordinates, if you will, to that point. I want some coordinates to that point. Well, here's what I know. This is an x value, right? And didn't I say that an x value, you want to think about cosine in this scenario? So if I had a triangle that was 1, 1, radical 2, did I make this circle bigger or smaller by doing that? What's the square root of 2? It's 1 point something. So technically, is it a unit circle still? Not really, but who cares? I want you to associate that 45, 45, 90 in there. What would the cosine of this thing be? 1 over the square root of 2, which ends up being, okay, cool. So, guess what? That's the x value.
Oh, is that how you're finding more of the unit circle? Dude.
Evan. Shut up.
I'm
What would the
figuring
y
out
then be?
math. Calm down.
The y would be the same, wouldn't it?
Hi. Oh, yeah.
What?
That's the part I can't do the unit circle.
Hold on, what? Did you not give me,
I can do the other part.
Does y
you can't do
sine-
sine, cosine, tangent? Of the 45s that we just did?
Well, yeah, but I get.
Okay, so let's do this then.
You makes me feel stupid.
Let's do, no, I don't want to make you feel stupid because I want you to understand what's happening here.
Well, no, I get
Let-
what's happening. I just get messed up all the time.
You okay with here?
Yeah, I
Okay, let's not even create the triangle.
Please stop talking.
No, yeah, well, kind of. If you don't want to create the triangle like I did, you don't have to. Because what do we know about this angle? We know it's 45, okay? And it really works for any 45 type angle, okay? What is the cosine of 45? We just said it. What is the cosine of 45? It ends up being radical 2 over 2, and then the sine ends up being radical 2 over 2, right? Let's do this. Let's make a 30-degree angle. Okay? Let me ask you this. What is the cosine? What is the cosine on 30 degrees? What is the cosine on 30 degrees? The cosine on 30. Cosine 30. I'm here. This is my point of view.
Square root of 3 over 2. I'm just saying numbers is what's there's only enough combinations.
Yeah, there are, aren't they? Isn't that cool? So few of them. So what is it? Mills, what'd you get? Boom! Radical 3 over 2. So, when I go here, guess what my x value is? What's my sign on 30? 1/2? There it is.
For some reason, I just remembered that.
I know, that's the only one that I know by memory. Let's make one more. Let's make one more. I'm going to make this is the 60-degree one, okay? This is the 60-degree one. What is... Don't give away the surprise. What is the cosine on 60? 1 over 2? What is the sine on 60? Radical 3 over 2? Cool.
Wait.
That's great. That's what you remember?
That's all I remember how to do.
Then we're done.
Okay, perfect.
Then we're done.
But what does this have to do with anything?
Well, this is a quarter of the unit circle,
This is
isn't it?
supposed to make your life difficult.
It don't not be a quarter.
Check this out. Because you know this already. You know this already. In quadrant 1, x and y are both positive. If I'm in quadrant 2, x is, y is. So this is going to be negative radical 2 over 2 comma radical 2 over 2. Right? Yes or no? If 45 is in quadrant 3, then what do I know about x and y? And if I'm in quadrant 4, right? Yes, no, maybe so? Let's transpose this 30 to kind of be in this direction. That means that x is now, whoop, I got too excited. I tried to make it pretty.
Just redo it. Just redo it.
Yeah.
Dang it.
You become like a mathematician so you can rename it the unit.
Right?
Where do you get the square root?
The square root of 2.
Yeah, like how do you get like from it being 1 over the square root of 2 to
You have to rationalize
square root
the
of 2?
denominator by multiplying it by another.
I was confused there.
Oh.
Okay, wait, okay.
Rationalizing the
I
denominator.
actually want to write this down.
Okay.
I know that.
Well, you already can write it down. Here's what I want everybody else to do. I want you to find all the others.
Yes, sir.
I want you to find all the others.
Yeah, that's what
I want you to find all the others.
Okay, right there.
He's playing Paul.
What Evan said yesterday, he was like, what wrong was my circle. I can't draw a circle. It's
I
a-
was
That's where I go wrong every time.
You literally have straight lines and you can't draw a circle. That is you see me in art. Yeah.
That's
So
a
wait, what are we
spirit.
doing now?
I'm gonna go cool off.
Cool. Oh, I'm sorry. I think I did it wrong.
Take this off.
Oh my goodness.
That's so cool, but so weird.
That's so,
Oh my god.
fourth grade.
What's the line?
Ah, damn it. Should've taken this off, otherwise I'll choke myself.
The thing is, I don't want to, Avery.
Oh no! Wait, what are you doing now?
Avery, I hate you.
No. Unless. Yeah.
Oh, I messed up my user search.
You're acting crazy right now. Here's mine, but it's not a circle. I kind of just put the coordinates. Chapstick and straw. Chapstick. The strawberry one or the cherry? Cherry is better. Yeah. That's what was in my house, so I think this was the ex-neighbor. I've been buying me chapstick. Not the mango one. I want to try like the coconut one. Oh no, the best kind of chapstick is Aloha coconut. That was so good.
I knew the brand. I knew the
Wait, you also bought him a car?
Yes.
Yeah, like this dude
Right at this moment, yes, I did.
on a four-wheeler.
I'm not a liar. I know the number.
Okay,
Wait, actually,
waterfalls. Sounds like you guys have this down.
I do.
Evan, what goes here then?
Negative square root of 3 over 2.
Comma.
Oh wait, that's, yeah, comma, negative 1 over 2.
Here.
Wait, so is it still the unit circle?
Mhm.
Square root of 3
We're just
over
finishing it up.
No,
What?
square root of 3 over 2, comma, negative 1 half.
What goes here?
Negative 1 half, comma, negative square root of 3 over 2.
Here.
1 half, comma, negative square root of 3 over 2.
And here.
1 half, or negative 1 half, comma, square root of 3 over 2.
Guys, that's the whole unit circle. It's supposed to make sense. Math don't like hard.
Let's take a picture. 'Cause
Hold on, I wanted to answer something from yesterday. Oh, you want to take a picture of it? Why? When you can just construct it again.
Well, 'cause mine looks like.
And you guys see where it came from? Where'd it come from? All right there.
Now, can you make one with all 3 of the ones we've done?
That is the one.
That's with all of
That's
them?
all of them. That is the unit circle that they give you that you look at and go, oh my god.
But there's no pies.
No pies? Oh.
Yeah, they're on 2 radians and degrees on them.
Evan, just find it on the internet.
No,
I want
well-
to learn it through the math.
Hold on. You don't need.
You learned it already.
Exactly. You already have these numbers, right? If you want radians, then. Well, why would you want radians? Radians is distance around the circle. Like, all you really. Oh, you're talking about angles, though.
Yeah.
No, what? You already know what they are.
Pi over 6.
You don't want to do all that. Whatever you need at that time, construct it, because it doesn't take long, right?
So why do we learn 3 unit circles if we're only going to use this one?
No. These are the values that you will use.
Okay.
The angles might be represented in radians.
Oh, okay.
That's the difference. But even if we did one in radians, all the numbers outside are the same.
So I should just keep all of them handy.
Sure. Or construct them, because it doesn't take long. All right, let me try to get through this real quick here. Oh, I missed one. So, everyone's okay with sine, cosine, tangent then? You guys know there's 3 more, correct?
Yeah.
So,
Cotangent, cosine. Yeah, stop.
sine, cosine, tangent. This is opposite over hypotenuse, adjacent over hypotenuse, opposite over adjacent. You're going to want to write these other 3. These are simply reciprocals. These are the reciprocal functions. Okay? The reciprocal of sine is something called cosecant.
Oh my god.
And we abbreviated C as C. And that is simply the hypotenuse over the opposite. Let me try to separate them for you here.
So just the opposite.
Not the opposite, the
inverse.
reciprocal. Okay? This is the reciprocal of cosine is secant. And we abbreviate SEC, that is hypotenuse over the adjacent. And then we have cotangent as the reciprocal of tangent. And we just abbreviate cot, and that is the adjacent over the opposite.
I thought you were taking this as a
Okay, that's pretty easy.
Now, I'll wait for you guys to copy that real quick. I whip my hair back and forth. I whip my hair back and forth.
Just do it.
I whip it.
And I do it so don't
That's the only song she got out too, huh?
Yeah. No, she has like a whole new album.
She has a whole new album?
Yeah, it's good too.
I am so out of touch there because, well, I'm not even listening to her in the first
It's
place.
nothing like that though.
We bumped into it like YouTube surfing and it was like, oh. And it looked really bright and stuff, and that was it. Other than that, it's like, okay. Alright, so
Best song though. Your best.
it's just catchy and kind of fun.
I'm gonna be singing it all day.
Awesome.
Not awesome.
Mamá el mechón.
Mr. Munoz, you have a lint roller.
You know what? No. And swear to God, I thought this morning about bringing one to school. And I
You see
didn't.
this? I look like a couch.
Or it was like I grabbed my sweater and had some stuff and I was picking them off, and I was gonna grab one and I was like I should just take it with me, and I put it down because I had to get my kids to school because they take forever. And well, goodness, please. All right. So here's the weird little trick to remember which is which, because I had a hard time, and like I'll try to find little things that are weird, and if you like it, good. If you don't, then figure out one for yourself. Cotangent is easy to remember because it sounds like tangent, right? So that's not the issue. The issue is between the other two. Now, these are reciprocals, right? If you look at the short version of secant, written backwards, looks like cosine. Looks like cosine. I said was. I said looks.
You know when you just look at
If you don't like it, find one for yourself. Looks like cosine. Looks like cosine. Therefore, that should be the reciprocal of cosine. And then there's SEC, which is the one that's left over. You like it, use it. You don't like it,
That's absolutely terrible.
get a new one and then show me.
Who's looking at it backwards?
I do. Like I said, you like it, use it. You don't, then just memorize it the way it is. Whoa, where'd you go? Don't do that. Okay?
Wait, how do you memorize the regular ones? Sin, sine. Yeah, it's true. I was like sin, cos,
What's the story that you're telling me?
There's no story. Let me get through some of these things first. Are we done? We did that. We did that. We did that. Domain, guys. Domain of the sine functions. Domain of the sine functions. Or sine and cosine. Negative infinity to positive infinity. The range is negative 1 to 1. We'll talk about that later. Why that makes sense. We did the reciprocals. Here's another way of looking at them, guys. Please write these down. Sine could be written as 1 over cosecant. Cosine could be written as 1 over secant. You can see them, I'll read to you. But tangent, you want to learn that. Tangent is sine over cosine, right? Y over x. You didn't like theta. We took theta out, we put t in there for you, bro.
No, I was getting used. I grew attached to the circle with a line.
Well, then change them from t to the circles with a line. Then change it back to theta.
But it's just.
Are you going to complain about everything today?
Probably.
Do you need a hug? Do you need a hug? Alright. I'm going to stop this.
Wait.
No, the recording. Just